Good morning. In today's class, we are going to discuss about two important topics. One is about electric flux density for various charge distribution. Another one is Gauss law. Okay. So initially, we are going to discuss about the electric flux density for various charge distribution. So we already discussed about the electric field intensity for various charge distribution. Like the same, now we are going to discuss about the electric flux density. So we know that the electric flux density capital letter D, which is equal to psi, that is pi divided by S, that is area. Okay. So from that we know that charge density rho is equal to Q divided by L. So in terms of Q means which is equal to rho into dl. Okay. In terms, if it is a line integral, Q is equal to line integral of rho into dl, or it may be surface means Q is equal to surface integral of rho dot ds, or if it is a volume integral, Q is equal to volume of rho into dv. Okay. So initially I am going to write the electric flux density formula, which is nothing but D is equal to Q divided by 4 by R square into AR vector. Okay. So finally we know that in terms of Q we are going to substitute integral of rho L into dl. So while we substituting rho L into dl, the equation becomes integral of rho L dl divided by 4 by R square into AR vector. Okay. In general, I am knowing the formula for electric field intensity for a line charge, which is nothing but rho L divided by 2 pi epsilon naught into AR. Okay. So generally D is equal to epsilon naught into E. So while we substitute here, which is equal to rho L divided by 2 pi R into AR vector. Okay. So finally, this must be a final equation for the electric flux density for a line charge in the form of two different L. So here rho L into dl divided by 4 pi R square into AR vector, or else if it is derived from the equation of D is equal to epsilon naught E means D is equal to rho L divided by 2 pi R into AR vector. Okay, like the same, if it is considered as a surface charge, rho is equal to coulomb per meter square. So Q is equal to surface integral of rho s into ds. By substituting in the equation D is equal to Q divided by 4 pi R square into AR vector. So in terms of Q, so integral of rho s into ds divided by 4 pi R square into AR. So like the same, with the help of electric field intensity, now I am going to calculate electric flux density from the formula D is equal to epsilon naught into E. So in general, we know that E is equal to rho s divided by 2 pi epsilon naught into AN vector. So this D is equal to epsilon naught into E, which is equal to rho s divided by 2 into AR vector. You should aware that this E is equal to rho L divided by 2 pi epsilon naught into R can be derived from the derivation electric field intensity due to infinite line conductor. Like the same, this E vector is equal to rho S divided by 2 epsilon naught can be derived from the equation electric field intensity due to circular disk. So from that, if I know the value of electric field for a line charge, means by means of D is equal to epsilon t, I can easily solve out the problem. Or else with the help of this derivation, I am going to find out the electric field intensity, electric flux density. Like the same, if I know the formula for the surface charge, that is electric field intensity due to circular disk, means from that I can able to find out the electric flux density with the help of D is equal to epsilon naught into E. Then while moving towards the volume charge, rho v is equal to the general specific charge density in terms of rho v is equal to coulomb per meter cube, because it is a volume integral. We know that Q is equal to volume integral of rho v into dv. So in general, D is equal to Q divided by 4 pi R square into AR vector. So while we substituting the values, Q is equal to means integral of, that is volume integral of rho into dv. So finally, the equation becomes volume integral of rho into dv divided by 4 pi R square into AR vector. So like the same, if I am knowing the equation, this can be easily derived from the equation of Coulomb's law. E is equal to rho v divided by 4 pi epsilon naught R square into AR vector. So finally, the equation D, that is the electric flux density can be represented in terms of epsilon naught into E, so rho v divided by 4 pi r square into AR vector. So the second half, that is in the session, the second half is the most important one, which is nothing but Gauss law. Okay, so Gauss law can be experimented from the Faraday's experiments. Okay, Faraday's experiments leads to the following statement, which is known as Gauss law. So finally, Faraday is only going to determine the Gauss law. So Gauss law, that is in a closed surface. For an example, if it is assumed or if it is assume a box, whatever may be, but should be a closed surface. In a closed surface, the total charge enclosed on the surface, Q, charge means Q, the total charge enclosed on the surface is equal to the total flux induced on the surface. This is a formula. Pi is equal to Q under closed surface. That is, the electric flux passing through any closed surface is equal to the total charge enclosed by the surface. Let us assume a diagram. This diagram we already seen in the calculation of electric flux density. So let us assume this is a ds, that is a surface integral r. Here it is considered as an electric flux density, and here it is considered as an electric field intensity. So the total d pi is equal to integral, that is in terms of vector form. So dot product in the E vector dot ds, which is equivalent to E dot ds dot cos theta. So in terms of pi means integral of E dot ds. Okay. Finally, from that equation, it is assumed that pi is equal to Q. That is, the inner closed surface, the total charge enclosed on the surface is equal to the volume enclosed on the surface. So from that proof, that is, I am going to prove that value pi is equal to Q with the help of spherical coordinate system. In the first unit, we may aware about the spherical coordinate system. That is, the charge may be in the form of three different coordinate system. One is Cartesian, another one is cylindrical, and the last one is spherical coordinate system. Here, I am going to use a spherical coordinate system to prove the Gauss law. So let us assume a spherical coordinate system. The three unknown terms r, theta, pi. Okay. So the three unknown terms r, theta, pi. R is a radius, theta is the angle of inclination, and pi is nothing but the rotational angle. Okay. We know the formula, electric field intensity is equal to Q divided by 4 pi epsilon naught r square. This is by means of Coulomb's law. So electric flux density, we may know the formula, D is equal to epsilon into E r else Q divided by 4 pi r square. By these two equations, so let us draw a spherical coordinate system. Okay, this is spherical coordinate system. Let us assume it is a point charge. So we may aware about there are four different types of charge distribution: point charge, surface charge, volume charge, and line charge. Here it is considered as a point charge. So let us consider spherical. So this may be the point of observation. So I am going to find out the electric field density, electric flux density D. So the distance between the point charge as well as the origin is considered as r, and the angle between them is theta, and the angle of inclination is considered as phi. This may be clearly explained in the unit 1 spherical coordinate system. Okay. So from that we know the formula. Okay. Let us consider it is a surface integral. We are not going for the volume integral, because in the first derivation itself I clearly mentioned that it is a surface integral spherical coordinate system. So I am here mentioned ds is equal to r into d theta, that r sin theta into d pi, because I am considering the radius of this sphere is considered as constant. Okay. So from that it is clearly understood that r square sin theta d theta d pi. Okay. We know that formula pi is equal to integral of d dot ds, which is equal to integral, that is surface integral of q divided by 4 pi r square into ds. On behalf of ds, I am going to substitute this value, because I am considering the example as a spherical coordinate system. Okay. So we know the integral. For the theta, the integral will be 0 to pi. For the pi, the integral will be 0 to 2 pi. So it is assumed as the constant value is taken out. That is q divided by 4 pi. R square is cancelled. Sin theta into d theta d pi. Okay. So we will be integrating and substitute the limit from upper limit to lower limit. And the final answer that I get is q divided by 4 pi into 2, while substituting the limit value upper limit 2 pi. So here it may be considered as 4 pi and it is 4 pi. So finally the answer becomes I is equal to Q. So this is mainly due to the electric flux crossing the surface. In a closed surface, the total amount of electric flux is equal to the total charge enclosed on the surface. So this is today's derivation, which is clearly understood about the basics of Gauss law. Okay.